Hi, good afternoon, everybody. Today we're looking at the third day of graphing rational functions. These are, um, we'll see in a second. Let's go ahead and just take a look at the first problem. Now, these are rational functions that are not in the form that we know when we're graphing, which is the form where we can actually graph, which is a over x minus h plus k. All right, these are not in this form, but we can easily put it in this form to allow us to graph it, and we do need it in this form so that we can recognize our asymptotes and our transformations. So it's simple enough. We just factor it if it's necessary, and then cancel out any factors that we have in the numerator and the denominator. However, we have to keep in mind that the simplifying process is just allowing us to graph this. We also, if you notice, our original problem here, x minus 2 and x plus 3 are factors of the denominator. These are going to have x values that cause our denominator to be equal to 0, which is an issue. And we'll talk about that in a second. So first, let's simplify this. The factor of x plus 3 cancels out, and we're left with 1 over x minus 2. Now this is easy enough to graph. We recognize it. The a value is 1, the h value is 2, the k value is 0. The vertical asymptote is x equals h, so x equals 2. Horizontal asymptote, y equals k, so y equals 0. So my asymptotes are going to be, let's see, right here at 2. And then also here at 0. Now I can build my table around my asymptote. My asymptote is at 2, my vertical asymptote. And I can build my table around that by plugging the values into this equation here and figuring out what their corresponding outputs are. So plugging in negative 1, 1 over negative 3, so negative a third. Plug in 0, 1 over negative 2, so negative a half. Plug in 1, 1 over negative 1, so negative 1. Plug in 3, 1 over 3, or 1 over 1, which is 1. Plug in 4, 1 over 2, which is a half. Plug in 5, 1 over 3, which is a third. Okay, so I'm just going to plot these points real quick so I know what this looks like right here, and right here. So something like this. And then on the other side, 3, 1, let's see, so right here, and right here. So something like this. Okay, now we can find the x and y intercepts by plugging in 0 for the other variable. So for the y-intercept, I can plug in 0 for x, and I actually already did that in my table. I plugged in 0 for x. So my y-intercept is 0, comma, negative 0.5, and we can see that on the graph. It's right here. I can find the x-intercept by plugging in 0 for y, and this is a little bit more complicated. It requires us to set the equation equal to 0. However, you can easily see this does not have a solution. Multiply by x minus 2, and you get 0 equals 1, which doesn't even make sense. And that's because there is no x-intercept, because that's where the asymptote is. The x-axis is the asymptote in this problem, so there's no x-intercept. Now, the only thing that's different about this graph, 1 over x minus 2, and what we're trying to graph, which is this right here, it has to do with that factor that we crossed out. Okay, we crossed out that factor x plus 3. Now, that factor still causes the denominator to be 0 of the original equation. And that's still going to pose a problem because your denominator cannot be equal to 0. And what this does is it actually creates a hole in the graph. The hole is going to be at negative 3 because that's the value that makes this factor equal to 0. So the hole is going to be at negative 3. That's the x coordinate. You can find the y coordinate by plugging it into this equation right here, which is the graph of this. The only difference between these two graphs this one, and this one, is that hole. Basically, that's it, the hole. So we can figure out where the hole is by just plugging it into this equation to see what it is. So what we get is 1 over -5, negative 0.2. So what we're going to do is we're going to go to that point and we're going to put an actual hole there to show that there's no point. So there, right here, -3, negative 0.2, we're going to put a hole because there is nothing there. Okay, there's no point there, so we'll put a hole. Now, when we're talking about the domain and range now, there are now more values that are not in the domain and not in the range. Okay, so the domain is everything except for the vertical asymptote, because there's no x coordinate at 0, or I mean at 2, because you can't plug 2 into this equation. There's also a hole. There's also a hole at -3, so there's no -3 in the domain because there's a hole there right here. There's no value for x being -3. It's not on the graph. There's nothing there. The range is similar. It's everything except for the horizontal asymptote, which is 0, and the hole, which the y-coordinate of the hole is -0.2. So essentially, these holes just give you more values that are not in the domain and range. They are restrictions on the domain and on the range. Okay, and this would be good for our graph here and for all of our information. All right, so let's take a look at the next one here. All right, so we got x plus 4 over x squared plus 3x minus 4. So this one's is pretty much the same, except you have to do the factoring yourself. So x plus 4 is a factor of the numerator. Denominator has factors of x plus 4 and x minus 1. The factors of x plus 4 cancel, so we're going to try to graph 1 over x minus 1. Okay, these two look the exact same. The only difference is this one is going to have a hole at -4. Okay, so our a value is 1, h value is 1, k value is 0. Vertical asymptote, x equals h, so x equals 1. Horizontal asymptote, y equals k, so y equals 0. I'm going to go ahead and put those on my graph. So asymptote at 1. And 0. And I'm going to fill out my table too. So I'm going to build my table around my asymptote at 1, my vertical asymptote. So 0, -1, -2, 2, 3, and 4. I'm going to plug these values into this so I can figure out where they are. You could plug it into this one, but this is just easier. So -2, so that's -1/3, -1/3. Plug in -1, 1 over -2, so that's -1/2. Plug in 0, 0 minus 1, 1 over -1 is -1. Plug in 2, 1 over 2 minus 1, so 1 over 1. Plug in 3, 1 over 2, which is 1/2. Plug in 4, which is 1 over 3, which is 1/3. Okay, and then I'm just going to plot these points on my graph. -2, -1/3 right here, and right here. And then on the other side, to 1, 1/2, and 1/3. Okay, so something like this. My y-intercept, you can find the y-intercept by plugging in 0, which we already did. Plugging in 0 gives you -1, so that's right here. You can find your x-intercept by setting the equation equal to 0. So I'm going to do that real quick. I can set the equation equal to 0. 1 over x minus 1 equals 0. But once again, If you try to solve this by multiplying both sides by x minus 1, you just get 0 equals 1, which doesn't make any sense. And that's because for this one, there is no x-intercept, because the x-axis is the asymptote. There's no point on the x-axis, so there's no x-intercept. Now we can focus on finding the hole. There is going to be a hole here because there's a factor that we crossed out, x plus 4. So there's going to be a hole where that factor is 0, because that would make the denominator 0, which is not allowed. So when x is negative 4, the hole, you'll see a hole there. I can figure out where this hole is by plugging negative 4 into this equation here. So I'll plug negative 4 into this equation here. So 1 over negative 5, so negative 0.2. So we'll go to negative 4, negative 0.2, and we will put a hole there. So something like that. That is also going to affect our domain, because our domain is usually everything except for the vertical asymptote. But now it's everything except for the vertical asymptote, and also there's no x value at the hole either. So x cannot be 1, x cannot be negative 4. Those are restrictions on the domain. For the range, everything except for y can't be 0, because that's the asymptote. Y also can't be negative 0.2, because that's where the actual hole is in the graph. Right, so this is our graph here for this problem. And that is it for the third part of graphing rational functions here.